Hey, Lunar Moss! Isaac here.
And Cameron.
People say that the moon landing is fake, and they have a right to do so.
The reasoning behind this is from documents like this.
Cameron,
Yeah?
I'm scared.
Why?
My hat's different.
My shirt's different.
Anyway,
Let's get back to it.
the most compelling argument that the moon landing is fake is because the moon is made of cheese.
And you can't land a rocket on cheese, because it's gonna melt.
And the moon isn't made of fondue, that's just silly. Accounts of the moon being made of cheese go back to the 1540s.
If this theory is true, what cheese is the moon made of? And what are its characteristics?
There are approximately 20,000 different types of cheese with their own unique characteristics and flavor. Let's just say the moon is made of Swiss, due to the fact that there are holes and craters most often in Swiss.
I think there are some holes in your theory.
The moon has a volume about 21.9 billion cubic kilometers, or 13.6 cubic miles, and a mass about 73.4 sextillion kilograms. Now that's a lot of cheese, but how many cows would you need to produce that much cheese?
The average cow produces about 6.5 gallons of milk per day. Every gallon of milk yields about 1 pound of cheese.
An average Canadian dairy farm has about 80 cows.
Therefore, thanks to dimensional analysis, shout out to my chemistry teacher, Miss Kendall, she drilled that into our skulls, to produce enough milk in 1 day to make the moon, you would need about 82 sextillion cows and 10 sextillion Canadian dairy farms.
To put that in perspective, there are only about 264 million cows currently living on Earth, which is a lot of cows.
Every cow produces about 501.8 liters, or about 132.5 gallons of methane per day.
That's a lot of cow farts.
Now, if humans devoted all of their resources to making Swiss cheese, using the current number of dairy cows on Earth, it would take us about 723,287 and a half years to make enough to milk enough cows to create enough cheese to make the moon. I am utterly exhausted just thinking about it.
That was before pre-humans settled the Philippines.
Quick thing about the Philippines. According to the International Euromonitor, they aren't that big a fan of cheese. They may use it as an ingredient or a spread, but most refuse to eat it plain. What do you have to say about that, Isaac?
The Swiss cheese moon would weigh about 24.1 sextillion kilograms, or 53 sextillion pounds.
That is 1.8 quintillion Priuses, or Pri, which is how Toyota wants the plural of Priuses to be.
Holy heck, Cameron, that's Gouda math on your part.
Thinking of cows, how much hay would you need to feed all those cows?
Well, if an average cow eats 24 pounds or 11 kilograms per day, they would need 4.6 quadrillion pounds or 22.1 quadrillion kilograms of hay to feed all of them. According to today's world hay production, that would take us about 22,000 years to grow enough hay. This was about the time early humans settled Australia.
Something about Australia. The most popular cheese in Australia is cheddar. it takes up about 55% of Australia's entire cheese market. On average, an average Australian consumes about 7.5 kilograms or 17 pounds of cheddar annually. But let's say we had no ordinary cow. Let's say we had the Cuban cow mentioned in Salmonella Academy. Psst. Hey Sam, let us know you wanna, do that collab, bro. We got you.
Do you mean Uber Blanc?
The very same.
Well, considering that she produced 110 liters or 29.1 gallons of milk per day, and we replace every cow on Earth with Uber Blancas, it would take us only a mere 111,797 years and a half to produce enough milk. Easy peasy, milky squeezy.
But how many calories would it be?
Well, in Swiss cheese, there's about 3.8 calories per gram. That means if you were to eat the Swiss cheese moon, then your total caloric intake would be 91.5 septillion calories.
That many calories would be enough to... I don't even know, guys. Let's put it this way. At the world's current rate of energy consumption, with the amount of calories in the Swiss cheese moon, we could power the entire Earth for 675 million years.
Or if you just decided to eat it in order to burn out those calories, you can go on a run for 26 quintillion years.
But cheese is a bit of a problem.
What's that, Cameron?
Well, cheese is not as solid as rock. Demonstrated by this clip. As you can see, here's our rock specimen. And it's time for the squish test. I'm applying some force. Isaac, what do you have to say on this matter?
It don't squish.
Thank you, Isaac. Cheese specimen, please. Thank you.
You're welcome.
Squish test beginning in 3, 2, 1. Isaac?
It squishes.
Thank you, Isaac.
So the cheese moon's own gravity will begin to separate the cheese particles into its basic components. This is because the bonds holding the cheese together will be broken by the moon's own gravity, pushing heavy elements into the center and the lighter ones to the surface. Thank you, Cameron.
You're welcome. This would do a few things.
For starters, it would make layers similar to what we have here on Earth. We're going to put the flat Earth theory for a side here, just for the moment.
Don't get salty about it.
Please don't.
All of this moving around would start to heat up the cheese moon quite a lot. Which begs the question. Could we have a cheese volcano? Maybe.
Let's think about that theoretically. Technically, we could have cheese volcanoes. Well, they probably wouldn't be made of cheese, but it would be spouting one of the many components of cheese. Do the whole, cheese being separated in its own crushing gravity. But if the moon gets hot, we could have gaseous cheese.
Think about it. This could cause cheese condensation.
That's right. Instead of having a defroster setting, you could have a decheeser setting.
On your car.
Which may just be a person from Wisconsin licking your windshield.
But what would its gravitational effects be?
The actual moon has a mass of 73.5 sextillion kilograms. No laughing at that, Cameron. And has a density of 3.34 grams per cubic meter, which we challenge because Swiss cheese isn't allowed to be that dense, so heck you, NASA.
But the Swiss cheese moon would only weigh about 24 sextillion kilograms instead of 73.5 sextillion. I want you to stop smirking because it's just a number.
Therefore, the Swiss cheese moon would have a gravity of 0.532 meters per second squared. That's 3 times less pull than the Moon currently does on the Earth.
This would obviously affect the Earth significantly.
For starters, tides, wave 'em goodbye.
And get ready for the seasons to be officially hecked. The rock moon stabilizes the Earth's tilt, which causes seasons.
Wait a minute, Cameron. Isn't the moon supposed to be all dusty?
Yeah, why?
Well, isn't dust... Well, if it wasn't dust, it was Parmesan. That, like the kind you put on spaghetti.
In conclusion, Wisconsin needs to chill on the cheese.
Have a great day.
And thank you all for watching.